Cofunction identities. Two videos ago, I presented the sum and difference identities for cosine. And not only did I present the theorem, I also proved the theorem. And it was quite a lengthy proof, and a proof that requires many explaining. So this is how our sum and difference identities look like. Cosine of alpha plus beta is equal to cosine of alpha times cosine of beta minus sine of alpha times sine of beta. And for the difference of two angles, cosine of alpha minus beta is equal to that. Okay? Many years ago, when I first saw this, coming from fundamental identities and Pythagorean identities, I found this to be like a big piece of information. And it's not easy to remember this at the first glance, although we will soon discover that there is rhyming to this. Cos minus sin. But the problem with that is, if you were to use that as the guide in memorizing the identity, the problem with that is the difference identity for cosine also rhymes in the same way. It's also cos and sin. But you know what? Just in case you are the type of person like me who has a resistance to memorize huge chunks of information, what you can do is you can just remember cosine of alpha plus beta, okay? And what you do is, if you want to write down, okay, so if you want to see what is the identity for the difference of two angles, the cosine of the difference of two angles, and you will apply the same identity, except that you will replace beta with cosine of negative beta. So cosine of alpha times cosine of negative beta minus sine of alpha times sine of negative beta. Okay? Now, this one is an even function, and we have an even identity for that. So that becomes cosine of beta. And then this one is an odd function. Sine of negative beta is negative of sine of beta. Okay? Negative sine of beta. And you know what will happen next? Because this is negative and this is subtraction. You know what will happen next? It will become plus sine of alpha times sine of beta. Okay? And so if you were now to compare this one with this one, they are the same. Example 3.41. Derive the cofunction identities. We shall show that this is true with the help of your sum and difference identities for cosine. But for the third one, look at this. Tangent of pi over 2 minus alpha, that is just equal to sine of divided by cosine of pi over 2 minus alpha. And since this one is equal to this, and cosine of pi over 2 minus alpha is equal to sine of alpha, this is just equal to cotangent of alpha. Okay? Okay, so let us prove or let us show that these identities are true. Let us show that this is true with the help of your sum and difference identities for cosine. So we will use this one, cosine of alpha minus beta. So cosine of pi over 2 minus alpha, okay, so we will use our cos plus sin. So cosine of pi over 2 minus alpha is equal to this. It's just the application of your difference of angles identity for cosine. Now, cosine of pi over 2, this one is equal to 0. So 0 times cosine of alpha is 0. Sine of pi over 2, this one is equal to 1. So 1 times sine of alpha. So there you have it. It's equal to sine of alpha. How about the second one? Okay, so the second one, the second cofunction identity is kind of tricky because we will use the earlier cofunction identity, the one that we just proved. How do we show it? So pay attention to this, okay? Cosine of pi over 2 minus alpha is equal to sine of alpha. So what I'm going to do is I will replace alpha with pi over 2 minus alpha, okay? I will replace it with pi over 2 minus alpha. So this is our identity. Cosine of pi over 2 minus alpha is sine of alpha. Again, I will replace alpha by, and that is equal to this. Sine of pi over 2 minus alpha using this cofunction identity. And pi over 2 minus pi over 2 is 0. Minus negative is positive. So you have there cosine of alpha. Cosine of alpha is equal to sine of pi over 2 minus alpha. And that is the second cofunction identity. Okay, so for the third cofunction identity, the one about the tangent function, I already spoke about this. We will just apply the first two cofunction identities, okay? So, tangent of pi over 2 minus alpha, this is a fundamental identity, so that is just equal to this, sine over cosine. But what is sine of pi over 2 minus alpha? We already know that it is equal to cosine of alpha. And cosine of pi over 2 minus alpha is equal to this, sine of alpha. So this one is equal to cosine over sine. Cosine of alpha over sine of alpha. And you know that this is among your fundamental identity. It is equal to cotangent of alpha.